In this video, I will talk a bit about data preparation. We'll talk about removing unhelpful variables, also examining correlations, and resolving collinearity problems. And I've selected this universal bank data set that we're going to use and tried various algorithms on in this exercise. And so let's go look at that. We need to do some preparation. Now, I've already done preparation that we normally do. I've already gotten rid of the data that is incomplete and any outliers, and so this data is pretty well ready to go, with the exception of a couple of issues. One is that we want to get rid of things that we know are not going to be predictive. So for example, something like ID is just a unique identifier, such as a social security number or just a customer number, and so it rarely is going to have anything that's going to be systematic in terms of helping us in terms of our predictions. So we can get rid of that by clicking on that, or control clicking or control right clicking, and you can see that they show up over here and get excluded. Zip code is sort of the same thing. Zip codes, remember, are numbers, but in fact they really are categories. And so we often will either need to change zip codes or group them together or remove them. So we've gotten rid of some stuff that we don't want, and we've set it aside. The next thing we need to do is we need to see how variables are related to each other and are especially related to our outcome variables. So this is what we're trying to predict in this case, is whether someone will accept the bank's offer to take out a personal loan. And we can see that if we look at these along the bottom here, we can see that income is the most highly related variable to whether or not people accept a loan. And there's also credit card average and whether or not they have a CD account. It's also, but there are others that really are not very strongly related. Some are so close to zero that they're almost zero, and they're unlikely to, it's not saying they can't, but they're often, when you see these very low correlations, they're not going to be as helpful in generating predictions, at least in linear predictions, as we would like. Now, KNN does not assume that things have to be linear relationships. It just finds examples that things as close to the record that we're trying to predict a value for as it can. But this is still always a good idea to come look at this. Also, we want to look for collinearity problems. Collinearity means that more than one input variable is highly correlated with another input variable. For example, in this case, the correlation is so high that it's almost 1. In effect, age and experience are essentially measuring. They're two indicators of someone's experience. And so this would confuse the model. Collinearity causes a number of problems when you run them in through a model. One is that something like this that is essentially the same will confuse the algorithms. It essentially is trying to find which inputs really make a difference, and essentially if you give it two that are exactly or so much alike, the algorithms can't do their job. And so a lot of data mining tools, including VisMiner, will just tell you, I can't do my work. You have to remove variables because they're so highly related. So we need to solve this problem. How do we do that? Well, this is so highly related that if we just include one of them, there's so much overlapping information in this that we won't throw away anything really important if we just include one. And how do you pick the one to include? Well, we look at how each variable is, how strongly correlated it is with the outcome variable. In this case, it's a negative 0.08, which is tiny, and then experience is also a negative 0.007, which is also tiny, but this is slightly less strongly correlated to the outcome variable than age is, and so we'll remove experience as well. So now we've removed that. If we look at credit card average and income, they are related, but it's not up to around 0.75 correlation, and so we can leave this in here. Sort of a general rule of thumb is that if you have a plus or minus 0.7 or 0.75, then that's usually something that you should take care of. And if you have something that's like 0.8 or 0.9, or in our example, we had a 0.99 correlations, one of those has got to go so that we don't confuse the models and make the models unstable. So now that we've gone through this preparation, we can create a subset of the data that will be useful for what we're trying to do. UBank. All right. So we'll create that. So now it went and selected just the ones that were left in this matrix and excludes these. So we'll shut this down, and then we'll partition the data. And in this example, we will let 40% of the data be in the validation and 60% be in the training set. And we're going to fix this random sequence so that when your algorithms run and my algorithms run, we're using the very same random selection process, so that so your records that get processed into the two groups and mine that get processed into the two groups will be exactly the same. If we don't do this, then our outcomes would be very similar, but they might be different a little bit, and that's sort of unnerving to students when they're learning something for the first time. So we'll fix this random sequence so that we're working on the data in the same way. Now we'll select all these variables and create our partition.